Hey, hey! We are moving into one-step equations. This is page 6. Page 6 of our notebook. In fact, the topic at the top is wrong. That's a typo. Gosh, Miss Edgstrom. I know. Cross that out. This is one-step equations. Sorry about that. If only I had people to proofread my work. Don't forget to fill in the date. Our essential question today is, how do I solve one-step equations? So that's really what we're looking at. How do I solve one-step equations? Whoa, that question mark got a little funky there. There we go. So those of you, if you're working on your own without our outline, you do have a lot to be writing down, so feel free to pause the video to make sure you're getting the full sentences. Those of us that are using this outline in the note packet, we're just filling in some of the blanks. So when we are solving one-step equations, this is a list of steps that you can follow. It's going to help remind you of what to do and how to be showing that work. So the first thing it says is to identify the operation. The first thing to do in a problem is to figure out what's happening. We want to identify the operation. Or you'll hear me ask a question, what's happening? That's the first question I ask, what's happening? That means I don't really care what you think about how to solve it. We're not to that point yet. We just want to know what's happening in this equation that's already in front of us. What's going on? One of the biggest things to remember here, and this is something, if you forget this, you're going to want to star this or highlight it. Remember that a fraction bar, the fraction, I'm going to put like a box around it. A fraction is also division. So you want to remember that a fraction is division. That's one of the big things. You might want to star it. You might want to highlight it if that's something you tend to forget. If you see a fraction when we're solving equations, I don't want you to be thinking about like, oh no, more fractions. Hate fractions. I want you to be thinking about, ooh, that's division. I don't even have to divide when I see it. I just know that that's division. And then once you know the operation, you're going to identify the inverse operation. Once you know what operation, then you can identify the inverse operation, or you can think about it as the opposite. The opposite operation. So if we see that we're doing that, it has addition, the opposite would be subtraction. Then what we're doing from there is we're going to eliminate the number. We want to get rid of the number that is on the same side of the equation as the variable. We want to eliminate that number by using the inverse operation. Then whatever you do on that one side, we have to do that on the other side. We have to keep our equations balanced. So whatever you do on one side of the equation, you must do to the other side. It is like a teeter-totter. If I have a teeter-totter, I'm trying to keep it balanced here. If I take something off of one side, I have to do the same to the other side to keep it balanced. If I add something on, I have to do it on both sides. We can't just take things away from this side and expect the equation to still be equal. If we have two values that are equal, whatever we do on one side to one value, we have to do to the other value as well. Then you always want to check your answer. This is a big one that we forget a lot. We think, ooh, I finally got the answer, I'm done, let's move on. But we want to slow down and we want to take time to check our answers. So let's try these steps out. Let's look at this first problem here, 7x equals 21. What operation is happening? What's happening? What operation is occurring in this problem? This is multiplication. This is 7 times x. So the way we undo that, the inverse operation of addition is what? Or sorry, oh my goodness, the inverse operation of multiplication is what? Division. So you can write division like this. We're gonna eliminate this on this side. So I always draw a line down my equal sign. Separates the two sides. I'm not worried about the 21 yet. I'm only looking at this side of the equation. 7 divided by 7 is what? Yeah, it's 1. So over here, all I have left after I do that division is I have 1x. Now step 4, whatever I did on this side, I also have to do on this side. This is an equation. This is part of why I draw that line down the middle, so that I can see if I did division over here, I have to do division over here. So 21 divided by 7 is 3. Now real quick, I just want to show you on this same problem, you're going to see fractions a lot, which means for me, when I do my work a lot, you'll see me write my division like this, make it a fraction. You'll see a lot of people do work like this. 7 over 7 is 1, and that leaves me with an x or 1x. Either is fine. If we do not have a number in front of our variable, it's a 1. This is 1x, this is also 1x. So either of these answers would be okay. You're mostly gonna see it written like this. We're mostly gonna not write that one, but you're more than welcome to. So let's try this one. 4 plus x, that's a plus sign. That's addition. That's our first thing. What's happening? We're adding 4 plus x. So what's the opposite? What's the inverse operation of addition? Yeah, it's subtraction. I want to get rid of this 4 by subtracting. 4 minus 4 is 0. 0 plus x, it's just going to be x, and that's what I really, really want, is I just want to know what that variable is. Whatever I did on one side, I have to do on the other side. X doesn't equal 30. 4 plus 30 is not 30. We have to subtract 4 from the 30. So 30 minus 4 gives me 26 for my answer. So some of you are able to do these in your head. You know that 7 times 3 is 21, or you might know that 4 plus 26 is 30. We're still going to show your work. And the reason being is we're going to find that we have a lot more difficult problems. We're going to get to decimals and fractions and all sorts of craziness and negatives, and we need to be able to organize our work. So one of the things we're practicing here is how to organize our work. This problem I'm going to write differently over here. I'm going to say that it is x divided by 5 equals 15. The reason I'm not going to show you work with that one in particular is because we almost never write it with that division sign anymore. We're almost always going to write it as fractions, so it's most important that you identify that when you see x over 5, that you recognize its division. How do we undo division? What is the opposite of division? Yeah, the operation that's opposite of division is multiplication. So often when I write this, I'm using those fractions, 5 over 1. Because if I multiply 5 times x over 5, just like I had over here, I'm going to have a 5 over 5. What is 5 divided by 5? That's a 1. That's what leaves me with just the x. When I multiplied on this side, I have to multiply on the other side as well. So 15 times 5. What is 15 times 5? Yeah, 15 times 5. You might know it in your head. I like to think of my 10 times my 5 and then my 5 times my 5. So 5 times 5 is 25. 10 times 5 is 55. That puts me at a, what, 75? Does that sound right? There we go, x equals 75. My very last one here is subtraction, x minus a 9. So like we've been doing, we're gonna put a line down our center, separate the two sides. What's happening is we have an unknown number and we're taking away 9. If we wanna undo that, instead of taking away 9, we're gonna add it back in. X minus 9 plus 9. So minus 9 plus 9, that makes 0. Those are gone. We still have the x. So I'm going to keep the x on that side. And whatever I do on one side, I added 9. That means I need to add 9 on this side. 3 plus 9, what is it? Yeah, 12. So x is equal to 12. And the biggest thing here is we have to be focusing on our work. It is fantastic if you can do this in your head. It is fantastic. But we have to start showing our work. Now, there are other ways you can show your work. I highly recommend what is called the T-chart here, this line down the middle. After every step, you show that you've completed that step. Now we're doing the math, the adding, the dividing, the subtracting. We're doing the work, just like when we used to do stacked multiplication and stacked addition and stacked subtraction. We want to show that we've done something. Here's the next answer. Here's the next equation. We're going to get to problems with like 5 steps involved, so it's really helpful if we can keep track of that we have done each step on both sides. We really want to make sure that that's happening. And so this line down our equal sign is really going to help with that. So if you do not like this way of showing work, I want you to talk with your teacher, see what other way you can show your work that's going to fully express what you're doing in your head that might, and we can talk about whether that's going to be helpful or whether it's going to make it more difficult when we get to harder equations, because part of what we're doing right now is preparing for when there's more steps, that we know how to organize our work and how to undo each of these operations.